Derivation of the laws of indices part 2. This has to do with the second law of indices. The second law of indices states that a raised power m divided by a raised power n is equals to a raised power m minus n. This is called the second law of indices. We shall be looking at this derivation in two ways, just like we did in the part 1, which has to do with the first law of indices. We shall be looking at it analytically, and of course we shall be looking at it arithmetically. So let's go analytically approach to deriving the second law of indices. Let's assume we have 2 raised power 5 divided by 2 raised power 2. This arithmetic and mathematically is as good as 2 raised power 5 is 2 times 2 times 2 times 2 times 2. And of course, divided by 2 raised power 2, that is 2 times 2. 2 raised power 5, which is 2 times 2 times 2 times 2 times 2, is equals to 32. Now divided by 2 times 2, that will give us 32 divided by 4. And that is equals to 8. This also could be written as 2 raised power 5 minus 2. And that is equals to 2 raised power 5 minus 2 is equals to 3. And 2 raised power 3, that will give us 2 times 2 times 2. And of course, 2 times 2 is 4. 4 times 2 is 8. And of course, 2 times 2 is 4. 4 times 2 is 8. And since this result and this result conform with one another, can therefore be concluded that 2 raised power 5 divided by 2 raised power 2 is equals to 2 raised power 5 minus 2, which would correspond or conform with the second law of indices. Now let's look at it from a more professional angle, otherwise known as the arithmetical approach. Let's derive the second law of indices using the professional approach. In this case, we already know, just like we did in the part 1, which has to do with the first law of indices, that a raised power m is as good as a times a times a times and so on times the exponent there is m, so we say m number of factors, n number of factors or places, m number of factors or places. Then a raised power n, a raised power n will be a times a times a times and so on times the exponent here is n, so it becomes n number of places of factors. Places of factors. Therefore, at this point, we say, okay, a raised power m divided by a raised power n becomes a raised power m divided by a raised power n. So let's substitute in the values or the expression for a raised power m and of course a raised power n from this particular expansion. So we have at this point a raised power m divided by a raised power n becomes equals to what now? That will give us what? Will give us a raised power m is a times a times a times and so on times m number of factors. M number of factors or places places all over, all divided by a raised power n, all over a times a times a times and so on times what is the exponent there? N number of factors. N number of factors. That is n number of factors. N number of factors or places places. So from this we have a raised power m divided by a raised power n is now equals to sum of the a's at the numerator, the denominator rather. We will take care of some of the a's at the numerator, leaving behind a times a times a times and so on into bracket m minus n, which is m minus n. Therefore, a raised power m divided by a raised power n will give us taking one of the a's, then the exponent becomes the m minus n number of factors, which is m minus what? N number of what? Factors. This is the derivation of the second law of what? Indices. And as you could see it, which is a raised by m divided by a raised by n, being equals to a raised by n minus 1, it conforms with indeed the what? The second what? Law of what? Indices. Which I'll be looking at what? The derivation of what? The third law of what? Indices, part what? 3. In this case, please do not hesitate to share, like, comment, and look forward to what? The part 3, which has to do with the derivation of what? The third law of what? Indices. Love you.